Have you ever stopped and wondered how we really know stuff? I mean, not just guessing, but truly, deeply know? Well, turns out there's a powerful toolkit for exactly that, and it's called research. It's how we systematically ask questions and actually find answers we can trust. So let's open up this toolkit and see what's inside. So here's our game plan. We're going to start at the very beginning with the basic building blocks of knowledge. Then we'll look at the two main paths our brains take to figure things out. We'll nail down what exactly makes an investigation real research. After that, we'll dive into the main tools researchers use and figure out the real purpose behind any big discovery. All right, so where does this whole quest for knowledge even begin? Before we can construct these big, amazing ideas, we have to talk about the foundation they're built on, the absolute bedrock. I mean, this is the big question, isn't it? For centuries, people have been trying to figure this out, and the most powerful system we've come up with all boils down to one central idea, and that idea is science. You know, at its heart, science is really just our best attempt to describe how the universe works based on stuff we can actually see and measure. It's not about opinions or beliefs, it's all about the evidence. And every single piece of evidence starts with one simple action. That's it. Just observation. It's the raw data we collect just by being alive and paying attention. You see an apple fall from a tree, you feel the warmth of a fire, you hear a weird noise your car is making. Those are all observations. And that's the first step in absolutely any scientific journey. But, you know, a big pile of random observations isn't all that useful. It's just a jumble of facts. We need something to connect the dots, to find the pattern. And that's where logic comes in. Logic is the engine of reasoning that lets us take those observations and make sense of them. Okay, but using logic isn't a one-size-fits-all kind of deal. It turns out there are two main highways our brains can take to get from a bunch of facts to a real conclusion. And those two paths are deductive and inductive reasoning. The easiest way to think about it is this. Deductive is top-down. You start with a big general idea and zoom in to see if a specific case fits. Inductive is the total opposite. It's bottom-up. You start with a small, specific observation and build your way up to a big idea. So the deductive path is super structured. Let's say you start with a big theory. All metals expand when heated. Okay. From that, you make a specific, testable hypothesis. If I heat this copper wire, it will get longer. Then you go and do it. That's your observation, and boom, confirmation. You've just used deduction to test a known rule. Now, the inductive path flips the whole thing on its head. This is all about discovery. You might start with just one observation. Hey, this patient has a fever and a rash. Then you see another patient with the same thing, and another. You start to see a pattern, and you make an inference. From there, you build a brand new theory. Maybe this specific virus causes a fever and a rash, and now you have a new idea that you can go and test. Okay, so we've got science, we've got observations, and we've got these two ways of thinking logically. But when does all that activity officially become research? Let's get a really clear definition.
Whoa, okay, let's unpack that, because there's a lot of good stuff in there. The key words are huge. Scientific means it's based on evidence. Systematic means it's not random, there's a plan. And ethical is absolutely critical. It means you're doing it responsibly and not causing harm. It's a focused search for an answer. And these right here, these are the ground rules. This is what separates just poking around from doing actual, rigorous research. It's got to be organized and ethical, for sure. But here are the big ones. It has to be replicable, meaning someone else can follow your steps and get the same result. It should be generalizable, so what you find isn't just a one-off fluke. And it must always, always be empirical, based on real-world evidence. So now we know the rules of the game, let's finally look inside that toolkit we talked about. Now, there are tons of specialized tools, but pretty much all of them fall into two main buckets. And this is the fundamental choice every researcher has to make. It all comes down to what you're trying to figure out. Are you dealing with numbers, or are you dealing with stories and descriptions? Are you counting things, or are you trying to understand an experience? On one side, you have quantitative research. Think quantity. It's all about numbers, data, and stats. You use big sample sizes, and you're usually using that deductive, top-down logic to test a theory. On the other side is qualitative. This is about quality. It's about words, feelings, experiences.
Here, you're working with smaller groups, sometimes just one person, and using that inductive, bottom-up approach to explore an idea. Honestly, the easiest way to keep them straight is to just think about the questions they ask. Quantitative research asks how many or how much. It gives you the hard numbers. Qualitative research asks the deeper questions. Why did that happen, or what does it feel like to go through that? You need both to get the full picture. All right, we've got one last major distinction to cover. And this one isn't about how you do the research, but why you're doing it in the first place. What's the end goal of the knowledge you're trying to find? This is the difference between basic and applied research. Basic research is all about curiosity. The goal is just to expand what we know about the universe, period. Think of a physicist studying subatomic particles, just to see what's there. There's no immediate goal. Applied research, on the other hand, is laser-focused on solving a real-world problem right now. It's about taking what we know and using it to, say, build a better medical scanner. And here's the thing, you absolutely cannot have one without the other. Basic research is what builds the foundation of knowledge. Applied research is what builds the house on top of that foundation. For decades, scientists did basic research on how crystals work with no goal in mind. And then, bam, that knowledge became the foundation for the applied research that gave us computers and smartphones. They're a team. So there you have it. From a simple observation all the way to a world-changing solution, research is really just a structured, powerful way of being curious. It's a toolkit that lets us turn "I wonder" into "I know." And the only thing you need to start is a good question. So what's yours?